Hello everyone, and welcome back to my third now web recording ever. Today I want to talk a little bit about the difference between linear and exponential growth. And I think by the end of the lesson we're going to find some pretty powerful things about the power of exponential growth. So first I want to take a look at the warm-up activity that's on the document that I posted online. And it talks about two different companies and their late policies. So company 1, on day 1, the penalty is $5. On day 2, the penalty is $10. On day 3, the penalty is $15. On day 4, the penalty is $20, and so on, increasing by $5 each day. So we can fill that in. So that'd be $5, $10, $15, $20, and this pattern continues. So you can fill that in on the worksheet. For company 2, on day 1, it's only a penny. And then on day 2 of company 2, it's double, so it becomes two pennies. On day 3, we double once again, so that we owe 4 cents. And then again by day 4, we owe 8, so only 8 cents. And so on, it'll continue to double. And I want you to take a minute, pause the video if you need to, and calculate out the rest of the table and try to figure out why Jim would be really upset if he decided to go with company 2 by the end of the 15 days. Pause the video now if you need a minute. So filling out the rest of the table, we can see that this pattern would just continue. So we would go 25, these would all be in dollars. And each week, we're just continuing by 5 more dollars than the week before. Not so bad. Your answers should probably be the same. You can check them right now. And eventually end up paying $75 on the final day. Why would Jim be upset? Well, what we come to find is that if we continue doubling at this pace, that soon it will be 16 cents. And then it would be 32 cents. Next we would have 64 cents. Followed by $1.28. And even still, by 8 days in, we're barely paying anything. So why would Jim be upset by day 15? Well, if we continue going, we end up $2.56, $5.12. So by day 10, the penalty is about the same as the day 1 of company 1. Just about, just a little bit more. Keep going, and we see that it's $10.24. And if we continue from there, $20.48. Now we start to see that we're building much more rapidly. Finally, on the 15th day, we end up with $163.84. Well over double of the penalty from company 1. So what happened? Why is this doing this? We see that company 2 clearly has the bigger late charge, but for what reason? Well, the reason we're going to talk about is exponential growth, and the idea that this repeating sort of sequence, and we're doing something a little bit different. If we had to figure out how much the penalty would be by day 20, if you did that on your own, as you saw on the worksheet, you would end up with already paying $5,242.88 for 20 days late. I don't know about you, but company 1 is sounding pretty good if I'm going to expect to be late on my payments. So if you had to write a formula to describe that would be a function to represent the data from company 1. If you had to do that, what do you think that would be? Take a second now if you need. If you came up with one, if you just unpause, you come up with something like f of n is equal to 5n, where n is the number of days, right? And each day goes $5 more, so it's 5 times the number of days. If you had to describe that sequence, would you say that it's arithmetic, geometric, or neither? And we would look at that one and we would say that that one is an arithmetic sequence because we are continuing with that pattern. of multiplying by 5 each time for each number. But then the sequence for this company too would be a little bit different. We would have to come up with something a little bit different, because instead of multiplying 5 times the number of days, we would actually be doubling the amount that we had times the number of days. So to this, we would use function like f of n is equal to 0.01 because of what we started with, and then each time we double it, so that's times 2. And now here's the question: should it be to the n, like the same number? And the answer is no, because our n started at 1. So if we were to put 1 there, this equation would say 0.01 times 2 to the 1, which is 2. So that would end up being, that would say that our first term would be 0.01 is what we want it to be, but if this was to be a 1, we would end up with 0.02. So we need to change this and make it n minus 1. And would this one be arithmetic, geometric, or neither? And the answer is geometric, because every time we're multiplying by a common factor. Instead of a common difference, we multiply by a common factor. And the penalty certainly grows much greater for the company too over time. So if you're going to pay back immediately, you might want to do this, especially if you're going to plan on doing it in the first 10 days. But if you think you're going to be late, you're going to run into some serious trouble down the road. So shifting gears, let's take a look at example number 1. If you haven't already, pause the video now to get a chance to read it. And if you just finished unpausing and you've just read it, I want to know, why would the ruler be surprised? What makes him think that it's such a modest prize to ask for? And the reason is, certainly 1 grain of rice on the first day does not seem like much. Even 2 on the second tile does not seem like much. Then you would ask for 4 on the third tile, right? And finally 8. And then after that, you'd ask for 16. Still, 16 grains of rice for the 5th tile, not a lot. But when we get a chance, we fill out that table, we see 16 grams of rice is going to quickly expand into something much, much greater. And we can write a similar exponential function to describe this situation. This one would be something like, on the first tile, we would write, 2 to the 0. We don't want to write 2 to the 1 or 2 to the n, because if we write 2 to the n, then we're going to end up with saying there's 2 tiles on the first. So instead, we say 2 to the 0, but by the second one, we say 2 to the 1. The third one is 2 to the 2. Fourth one is 2 to the 3. This one is 2 to the 4. And if you haven't noticed the pattern yet already, we're looking at again the formula 2 to the n minus 1. But this time the starting value here was a 1. So this is easy enough to see that when we need to calculate the pattern, we can look at, well, what tile are we on? For the 62nd tile, we can use 2 to the n minus 1, so it'll be to the 61. Here would be 2 to the 62. And finally here would be 2 to the 63. 2 to the 63 is a very large number. If you haven't had a chance yet, plug that into your calculator and see how big that is. Quite a large number, right? So it goes to say, I don't think the king was able to pay off that much rice. And by the time the treasurer was able to finish, they didn't have enough rice, and all of a sudden the inventor of the game of chess had become the owner of the land. So it pays to have a little math, be a little bit more clever than your opponents. So we've seen a lot about the power of exponential functions. So what really is so different about exponential functions